Hello everyone, now we are going through exercise 10.2. First question, compute the magnitude of the following vectors. Here we have to find the magnitude of given vectors. First vector, vector A is equal to I plus j plus k. Magnitude is nothing but modulus vector A. Magnitude of vector A is modulus vector A, that is equal to square root of coefficient of I 1 square plus coefficient of j 1 square plus coefficient of k 1 square, that is equal to root 3. So root 3 is the magnitude of vector A. And vector B, modulus of vector B is equal to square root of coefficient of I is 2 square plus coefficient of j is minus 7, so minus 7 square plus coefficient of k is minus 3, so minus 3 square, that is equal to square root of 4 plus 49 plus 9, that is equal to square root of 58, 62, square root of 62. Okay, next is magnitude of vector C, that is modulus vector C, that is equal to square root of coefficient of I is 1 by root 3, so 1 by root 3 whole square plus 1 by root 3 whole square plus 1 minus 1 by root 3 whole square, that is equal to root of 1 by root 3 whole square is nothing but 1 by 3, 1 by 3 plus 1 by 3 plus 1 by 3, that is equal to root of 3 by 3, that is root 1, so 1. Okay, so here modulus of A is equal to, that is magnitude of vector A is equal to root 3 and magnitude of vector B is equal to square root of 62, magnitude of vector C is equal to 1. Write two different vectors having the same magnitude. So here for this, first of all, let's take any vector. Vector A is equal to I plus 3j minus 2k. Okay, we have taken any vector. Okay, a vector, that is vector A is equal to I plus 3j minus 2k. See, what are the coefficients of I, j and k? 1, 3, minus 2. So here we just change the position of these vectors, that is coefficients. Okay, so here we can write vector B is equal to 3i, okay, minus j plus 2k. 3 minus 1, 2. Okay, see here we find, having the same magnitude, vectors having the same magnitude means, see, if a vector A and vector B are the vectors, then modulus of vector A should be equal to modulus of vector B, right? That is, when we take the modulus, means magnitude means square root of that is x square plus y square plus z square, right? So we are taking the squares of these numbers. So if it is minus or plus, it will be same, right? So here you just remember, take these numbers, that is coefficients, you just change the position of the coefficients. Okay, so here 3 minus 1, 2, 1, 3 minus 2. Okay, let's check. Modulus of vector A is equal to square root of 1 square plus 3 square plus minus 2 square, that is equal to square root of 1 plus 9 plus 4, that is square root of 14. Modulus of vector B is equal to square root of 3 square plus minus 1 square plus 2 square, that is equal to 9 plus 1 plus 4, that is equal to square root of 14. So here we have got magnitude of these vectors, vector A and vector B are same. Write two different vectors having the same direction. Here we have to write two vectors having the same direction, right? So here we studied that vector A and vector 2A have the same direction, right? Generally we can say, if vector A is a non-zero vector non-zero vector, and lambda is positive scalar, then vector A and lambda vector A have same direction. Okay, that is, if vector A is a non-zero vector and lambda is a positive scalar, then vector A and lambda vector A have same direction. Keep it in your mind. Okay, so for that here we have to write two vectors having the same direction, right? So first of all, let's write any vector. Okay, first vector, any vector, that is I. Let's write vector A is equal to I plus j minus 2k. Okay, next, what is vector B? Let's multiply 2 by this vector, that is 2i plus 2j minus 4k, that is 2 into vector A, right? 2 into vector A. Therefore, here vector A and vector B are the vectors having the same direction. Find the values of x and y so that the vectors 2i plus 3j and xi plus yj are equal. So, two vectors are equal, then their corresponding components are equal, right? So, here two vectors are equal, means 2i plus 3j is equal to xi plus yj, right? That is, their corresponding components are equal. Therefore, here we will get x is equal to 2, y is equal to 3. That's all. So, values of x and y are 2 and 3 respectively. Find the scalar and vector components of the vector with initial point 2, 1 and terminal point minus 5, 7. Okay, so let A be initial point, that is initial point is 2, 1, A of 2, 1. Okay, and B be terminal point, let B be terminal point, that is this point is B of minus 5, 7. Okay, so here we have to find vector AB, and here see we have three-dimensional plane, xyz plane, and here z coordinate is 0. There is no k component. Okay, so here let's join these points from the origin. Okay, and by the triangle law of vector addition, we can say vector OA plus vector AB is equal to vector OB, right? By triangle law of vector addition, vector OA plus vector AB is equal to vector OB. We have to find vector AB, right? That is, vector AB is equal to vector OB minus vector OA. So, what is vector OB? See, vector OB is nothing but, here it is origin, right? So, minus 5i plus 7j. There is no k component, okay? That is, vector OB is equal to minus 5i plus 7j. And what is vector OA? Vector OA is 2i plus j. 2i plus j. Okay. Then let's find vector AB. Vector AB is equal to vector OB minus vector OA. That is, vector OB is minus 5i plus 7j minus 2i plus j. Minus 5i, that is minus 5 minus 2 is minus 7. So, minus 7i plus 7 minus 1, that is plus 6j. So, minus 7i plus 6j. Vector AB is equal to minus 7i plus 6j. Here we have to write what are the scalar and vector components of the vector AB. Okay, that is, scalar components are minus 7 and 6. Okay, and vector components minus 7i and 6j. Minus 7i and 6j are the vector components, and minus 7 and 6 are scalar components of vector AB. Find the sum of the vectors. Vector A is equal to I minus 2j plus k. Vector B is equal to minus 2i plus 4j plus 5k. And vector C is equal to I minus 6j minus 7k. So here how to add? Vector A plus vector B plus vector C is equal to, that is adding corresponding coefficients of I, j, k, right? That is I minus 2j plus k plus minus 2i plus 4j plus 5k plus I minus 6j minus 7k. So add corresponding coefficients of I, j, k. That is here 1, coefficient of I is 1. So 1 minus 2 plus 1, right? 1 minus 2 plus 1 into I plus minus 2 plus 4. So minus 2 plus 4 minus 6 into j plus k coefficient 1 plus 5 minus 7k. Okay. That is equal to here 0i, that is it is 0. Next is minus 2, minus 2, minus 6, minus 8, minus 8 plus 4, minus 4j plus 6 minus 7, that is minus 1. So minus k. So it is the sum of given 3 vectors. Find the unit vector in the direction of the vector. Vector A is equal to I plus j plus 2k. We have already learnt the unit vector in the direction of vector A is equal to 1 by modulus of vector A into vector A. Right? That is, unit vector in the direction of vector A is 1 by modulus of vector A into vector A. Right? Therefore, here we have to find the unit vector in the direction of the vector. Vector A is equal to this one. That is, so let's find, that is unit vector in the direction of vector A is equal to 1 by modulus of vector A into vector A. So here let's find what is modulus of this vector. That is magnitude of given vector. Modulus of vector A is equal to square root of 1 square plus 1 square plus 2 square, right? That is square root of 6. Okay. Then let's write what is the unit vector in the direction of given vector. So unit vector in the direction of vector A is equal to 1 by root 6 into vector A is I plus j plus 2k, right? That is 1 by root 6 I plus 1 by root 6 j plus 2 by root 6 k. It is the unit vector in the direction of given vector. Find the unit vector in the direction of vector PQ, where P and Q are the points 1, 2, 3 and 4, 5, 6 respectively. So here we have to find the same unit vector in the direction of vector PQ. But here first of all we have to find what is vector PQ. Okay, so we have to find vector PQ. It is given initial point 1, 2, 3 and final point 4, 5, 6. So here we can find a vector PQ. That is, see, let's take P this point initial point P of 1, 2, 3 and terminal point, that is 4, 5, 6. Q of 4, 5, 6. Okay, it is vector PQ. Now here, so suppose it is the origin O, then let's join these points. Okay. And we know that vector OP plus vector PQ is equal to vector OQ, right? That is vector OP plus vector PQ is equal to vector OQ. And here we have to find vector PQ, right? That is vector PQ is equal to vector OQ minus vector OP. So what is vector OP and what is vector OQ? See here, vector OQ is equal to 4, 5, 6 are the points, right? X coordinate, Y coordinate, Z coordinates. Okay. So here 4i plus 5j plus 6k. Okay. Vector OQ is nothing but 4i plus 5j plus 6k. And vector OP is equal to I plus 2j plus 3k. Okay, now we have vector OQ and vector OP. We can find vector PQ, right? So vector PQ is equal to vector OQ minus vector OP. What is vector OQ? This one, right? That is 4i plus 5j plus 6k minus I plus 2j plus 3k. That is 4 minus 1, 3i, 5 minus 2 plus 3j, 6 minus 3 plus 3k. Okay. So vector OQ, vector PQ is nothing but we have got vector PQ is 3i plus 3j plus 3k. Then next we need to find unit vector in the direction of vector PQ. We know that unit vector in the direction of vector A is equal to 1 by modulus of vector A into vector A, right? That is here unit vector in the direction of vector PQ is equal to 1 by modulus of vector PQ into vector PQ. Isn't it? So let's find modulus of vector PQ. That is modulus of vector PQ is equal to square root of 3 square plus 3 square plus 3 square. That is 9 plus 9 plus 9. Square root of 27. Okay. So modulus of vector PQ is equal to, see this can be written as square root of 9 into 3, right? That is equal to 3 root 3. Okay. 3 root 3. So here that is unit vector in the direction of vector PQ is equal to 1 by 3 root 3 into vector PQ, that is 3i plus 3j plus 3k. Okay. That is equal to 3i, 3 divided by root 3. Sorry, 3 root 3. 3 divided by 3 root 3, that is 1 by root 3i. Plus here also 3 divided by 3 root 3, 1 by root 3j, 3 cancelled, right? 3 divided by 3 root 3, that is 1 by root 3k is the required unit vector. Find a vector in the direction of vector 5i minus j plus 2k which has magnitude 8 units. Here we have to find a vector and it's in the direction of vector 5i minus j plus 2k. And the required vector has magnitude 8 units. Okay. So here first of all we will find the unit vector in the direction of this vector, given vector. Okay. Because here this vector and required vector and given vector have same direction. Okay. So let's find the unit vector in the direction of the given vector. That is the unit vector in the direction of required vector. Right? Okay. So let's find, let's take vector A is equal to 5i minus j plus 2k. Okay. Now we have to find the unit vector of vector A. That is For that we need to find modulus of vector A, right? That is square root of 5 square 25 plus 1 plus 4, that is square root of 30. Next, unit vector along the, in the direction of vector A, in the direction of vector A is equal to 1 by modulus of vector A into vector A. That is 1 by root 30 into vector A is 5i minus j plus 2k. That is equal to 5 by root 30 I minus 1 by root 30 j plus 2 by root 30 k. It is the unit vector along the direction of vector, given vector. Okay. Now we have to find the vector along the direction of the same vector which has magnitude 8 units. Okay. See, it is the unit vector, right? So its magnitude of unit vector is 1. Okay. Now to find the required vector, we have to multiply 8 by this vector. Okay. That is, required vector is equal to, that is 8 into a cap. That is, it is the unit vector. Okay. It is the unit vector. So multiply by 8, we will get required vector. Okay. That is equal, because 8 is the magnitude of required vector. It is given this vector has magnitude 8 unit. Okay. Therefore, required vector is equal to 8 into this unit vector. Okay. That is 8 into 5 divided by root 30 I minus 1 by root 30 j plus 2 by root 30 k. That is equal to 8 into 5, 40, 40 by root 30 I minus 8 by root 30 j plus 16 by root 30 k. So it is the required vector. Show that the vectors 2i minus 3j plus 4k and minus 4i plus 6j minus 8k are collinear. We learned that two vectors are collinear if they are parallel to the same line. Right? See, that is, here we studied that vector A and vector 4a are collinear. Right? Because they are parallel to the same line. So here given vectors, vector A is equal to 2i minus 3j plus 4k and vector B is equal to minus 4i plus 6j minus 8k. See, this can be written as, here let's take minus 2 outside, so it will be 2i minus 3j plus 4k, right? That is minus 2 vector A, right? See, here vector B is the scalar multiple of vector A. Therefore, vector A and vector B are collinear. Okay? Vector A and vector B are collinear since vector B is a scalar multiple of vector A. Find the direction cosines of the vector I plus 2j plus 3k. It's very important how to find the cosine direction cosines of a given vector. So for this, so first of all, let r is equal to I plus 2j plus 3k. That is position vector. Okay. Next we will write direction ratios of this vector. That is direction ratios. Okay, let's take A is equal to direction ratios. A is equal to 1, B is equal to 2, C is equal to 3. Okay. Then let's find the magnitude of vector R. That is modulus vector R is equal to square root of 1 square 1 plus 2 square 4 plus 3 square 9. That is square root of 14. Right. Then direction cosines are direction cosines are A divided by modulus of vector R, B divided by modulus of vector R, C divided by modulus of vector R. That is 1 by root 14, 2 by root 14 and 3 divided by root 14 are the direction cosines of given vector. Find the direction cosines of the vector joining the points A of 1, 2, minus 3 and B of minus 1, minus 2, 1 directed from A to B. Similar question, here also we have to find the direction cosines of the vector. Here vector is not given but vector joining the points are given. Okay, so let's find the vector. It is the point A of 1, 2, minus 3 and B of minus 1, minus 2, 1. And it is given that directed from A to B. Okay, let O be the origin. Join these points. Vector OA by triangle law of vector addition. This can be written as vector OA plus vector AB is equal to vector OB. We need to find vector AB, right? That is, we have to find the direction cosines of the vector AB. So vector AB is equal to vector OB minus vector OA. What is vector OB? Vector OB is minus 1i, that is minus I, minus 2j plus k, minus vector vector OA, that is I plus 2j minus 3k. That is equal to minus 1 minus 2i minus 2 minus 4j plus 1 minus minus become plus, so 1 plus 3 4k. Okay, next here we have got vector AB, right? Next we have to find the direction cosines. For that we need to write direction ratios of the vector AB. Direction ratios are of vector AB are minus 2, minus 4, 4, right? Then we need to find its magnitude. Okay, that is modulus of vector AB is equal to square root of minus 2 square 4 plus minus 4 square 16 plus 16, that is square root of 36 is 8. Sorry, 6. Right? Okay. Then after that we will write direction cosines of this vector. Direction cosines of vector AB are minus 2 divided by 6 minus 4 divided by 6, 4 divided by 6. That is minus 1 by 3. It is minus 2 by 3, 2 by 3 are the direction cosines of the vector joining the points A of 1, 2, minus 3 and B of minus 1, minus 2, 1. Show that the vector I plus j plus k is equally inclined to the axis OX, OY and OZ. That is, here we have to prove cosine values of the angles made by the vector are equal. Okay, that means direction cosines are equal. Okay, if the direction cosines are equal, we say that the given vector is equally inclined to the axis OX, OY, OZ. Okay, that is cos alpha, cos beta, cos gamma are equal. Okay, so for that let's find the direction cosines. See here let R is equal to vector, given vector I plus j plus k. Okay, then now to find the direction cosines, so let's write the direction ratios. Direction ratios of vector R is equal to 1, 1, 1, right? And and direction cosines. Okay, for that we need to find the magnitude of this vector, right? That is modulus vector r is equal to square root of 1 square plus 1 square plus 1 square, that is square root of 3. Okay. Then direction cosines are 1 by root 3, 1 by root 3, 1 by root 3. We have got direction cosines are same. That is 1 by root 3, 1 by root. That means cos alpha, cos beta and cos gamma are 1 by root 3. Okay, cos alpha is equal to cos beta is equal to cos gamma. Therefore, we can say the given vector is equally inclined to the axis OX, OY, OZ. Okay, therefore, vector I plus j plus k is equally inclined to the axis OX, OY and OZ. Find the position vector of a point R which divides the line joining two points P and Q whose position vectors are I plus 2j minus k and minus I plus j plus k respectively in the ratio 2:1 internally and externally. Okay, these things we have already studied in 11th standard lines chapter. Okay, so here now let's see. It is given. So let's take let a vector A is equal to position vector of P. Position vector of P that is equal to I plus 2j minus k. Okay. And let vector B is equal to position vector of Q that is equal to minus I plus j plus k. Okay. After that, Q divides PQ, R divides PQ internally in the ratio 2:1. Then vector OR is equal to, that is 2 into vector B plus 1 into vector A divided by 2 plus 1. This formula we have studied, that is equal to 2 into vector B, that is this vector minus I, directly we will write minus 2i plus 2j plus 2k plus 1 into A, that is this vector I plus 2j minus k divided by 2 plus 1, 3. Okay, that is equal to minus 2i plus 1 minus I plus 2 plus 2, 4j, 2 minus 1, 1k divided by 3. That is equal to, okay, that is vector OR is equal to minus 1 by 3i plus 4 by 3j plus 1 by 3k. Next is it divides externally. Okay, so let S be divides vector PQ externally in the ratio 2:1. Therefore, vector OS is equal to, that is 2 into, what is our vector? Here vector A is equal to this one, right? I plus 2j minus k, and vector B is equal to minus I plus j plus k, right? So here 2 into vector B, that is vector B minus 1 into vector A divided by 2 minus 1. It is the formula, okay? That is equal to 2 into vector B is minus 2i plus 2j plus 2k minus here I minus of I plus 2j minus k divided by 2 minus 1, 1. That is equal to minus 1 minus 2 minus 1 minus 3I plus 2 minus 2, that is 0. Next 2 minus 1, that is 2 plus 1, so plus 3k. So it is the vector OS. Find the position vector of the midpoint of the vector joining the points P of 2, 3, 4 and Q of 4, 1, minus 2. See here, this also we have studied finding the midpoint of a line joining two points, right? Suppose it is our, PQ, okay, and it is the midpoint R. It is given, line joining the points are given P of 2, 3, 4 and Q of 4, 1, minus 2. Now we can find R, right? So here it is the origin O. Then we have to find the vector OR. We have to find vector OR. That is the position vector. Okay? That is the position vector of the midpoint of the vector line, the vector joining the points P and Q. Okay? So it is the midpoint. So here we can find the midpoint. Right? How to find? The midpoint of PQ is equal to, that is we studied x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? That is equal to 2 plus 4, that is 6 divided by 2, 3 plus 1, 4 by 2 and minus 2 plus 4, 2 divided by 2. That is 3, 2, 1. So this point R is nothing but 3, 2, 1. And what is the vector OR? So vector OR is equal to 3I, right, plus 2j plus k. So it is the position vector of the midpoint of the vector joining the points P and Q. Show that the points A, B and C position with the position vectors, vector A is equal to 3I minus 4j minus 4k, vector B is equal to 2I minus j plus k and vector C is equal to I minus 3j minus 5k respectively from the vertices of a right angle triangle. It's very important question. So here we have to prove the points A, B, C form a right angle triangle. That is what we have to prove. That is a characteristic of right angle triangle is, that is Pythagoras theorem, that is if it is a right angle triangle ABC, then we have to prove AC square is equal to AB square plus BC square, right? So here let us take these 3 points A, B, C, okay, and it is given the position vectors, that is let's take AB is equal to vector A. Sorry, the position vectors, okay, position vectors, that is from the origin, okay, it is the point O. And OA, vector OA, let's take vector OA is equal to vector A. And vector OB, that is equal to vector B. And vector OC, that is equal to vector C. Okay. Now here we have to prove the triangle, that is the points form a triangle, that is right angle triangle. Okay. For that we have to prove this AC square is equal to BC square plus AB square. Okay. So for that we need to find AB, BC and AC. So here what is vector OA? See, vector OA is equal to this one, right? So here we can find vector AB, right? Vector, because by triangle law of vector addition, we can write vector OA plus vector AB is equal to vector OB, right? So from this we can write vector AB is equal to vector OB minus vector OA, right? Vector OB minus vector OA, that is equal to, what is vector OB? That is vector B. Vector B is 2I minus j plus k minus vector OA, that is vector A, 3i minus 4j minus 4k, right? That is equal to, here 2 minus 3 minus I minus 1 minus minus 4 plus 4, that is minus 1 plus 4 is plus 3j, 1 minus minus plus, so 1 plus 4 plus 5, so plus 5k. So it is the vector AB, okay, vector AB. After that, next we will find vector BC. See how to find vector BC? That is by the triangle law of vector addition. Here vector OB is equal to vector BC plus vector OC, right? That is, here we can write vector BC is equal to vector OB minus, sorry, vector OC minus, okay, vector OC minus vector OB, right? That is equal to, what is vector OC? Vector C, right? That is I minus 3j minus 5k minus vector OB, that is vector B, 2i minus j plus k. That is equal to 1 minus 2 minus I minus 3 plus 1 minus 2j minus 5 minus 1 minus 6k. So it is vector BC. Next we will find vector BC, then vector AC, okay, vector AC. That is equal to, here how to find vector AC? That is vector OA plus vector AC is equal to vector OC, right? Therefore vector AC is equal to vector OC minus vector OA. That is equal to, here what is vector OC? Vector C, I minus 3j minus 5k minus vector OA, that is 3i minus 4j minus 4k. That is equal to 1 minus 3 is minus 2i minus 3 plus 4, that is plus 1j minus 5 plus 4 minus k. Okay. So here we have got three vectors, vector AB, vector BC, vector AC. Then let's find the magnitudes of these vectors. Okay. That is length of these sides, right? So what is vector modulus of vector AB? That is equal to square root of minus 1 square 1, 1 plus 9 plus 25, that is equal to 10 plus 25 root 35, right? Next, modulus of vector BC, that is equal to square root of minus 1 square 1 plus 4 plus 36, right? That is 5 plus 36 root of 41, right? Next, modulus of vector AC, that is equal to square root of 4 plus 1 plus 1, that is equal to 5, 6 root 6. Okay. Now here, see, we can write it as modulus, see, it is root 35 and root 6. So here, what is AB square? Means that square, that is square of this length. Okay, that is AB whole square. Means here AB square is equal to 35 and BC square is equal to 41 and AC square is equal to 6. Okay. Then here, see, we can write AB square plus AC square, that is equal to BC square, right? So that is AB square plus AC square is equal to 35 plus 6, that is equal to 41, that is equal to BC square. So by Pythagoras theorem, we can say it's a right angle triangle. Okay. Therefore, these points A, B and C form a right angle triangle. In triangle ABC, which of the following is not true? Here, vector AB plus vector BC plus vector CA is equal to 0. See, first of all, let's write by triangle law of vector addition. Vector AB plus vector BC is equal to vector AC, right? By triangle law of vector addition. So, or we can write, see this one, vector AB plus vector BC is equal to, we know that vector AC is equal to minus vector CA, right? So that implies vector AB plus vector BC plus vector CA is equal to 0. So it is correct, right? And this one, see, if you take this vector AC left side, it will be this one, right? Vector AB plus vector BC minus vector AC is equal to 0. And next is, see, it is vector AB plus vector BC. Vector AB, vector BC can be written as minus vector CB, right? Okay, vector BC is equal to minus vector CB plus vector CA is equal to 0. So, it's also correct. This one, these three are correct. Next, here it is not correct. That is, vector AB plus vector BC minus vector CA is equal to 0 is not true. So, it is the answer. If vector A and vector B are collinear vectors, then which of the following are incorrect? Vector B is equal to lambda vector A for some scalar lambda. It's true, right? Vector B is equal to, that is scalar multiple of vector A, then vector A and vector B are collinear vectors. Vector A is equal to plus or minus vector B. Here also vector B, that is vector A, is the scalar multiple of vector B. Here lambda can be plus positive or negative. Okay. And here the respective components of vector A and vector B are proportional. The same meaning, right? So here also vector A is the scalar multiple of vector B. So therefore here also vector A and vector B are collinear vectors. Both the vectors vector A and vector B have the same direction but different magnitudes. That is wrong, right? So here, because we studied that vector, if two vectors are collinear vectors, if they have the same direction, that is parallel to the same line, right? Means here that is irrespective of direction and magnitude. Okay, here doesn't matter about magnitude and the direction. So here both the vectors vector A and vector B have the same direction but different magnitudes. It's false. It's not true. Okay, therefore it is the incorrect statement. Therefore it is the answer. Okay.